Good morning, class. Today we are on book 4, lesson 21 of our Saxon math book. Today's lesson is triangles, rectangles, squares, and circles. Oh my! So the first example says to draw a triangle that has 3 sides that are all the same length. So typically when we start drawing a triangle, we're going to go like this. But if we do that, we can see that these two sides, they look pretty close to being the same, but this side is not going to be the same. Another way we sometimes draw a triangle is to make an L first and then to connect. And once again, we might end up with two sides the same here, but this side is not going to be the same length if we would get a ruler out and measure it. So, a triangle that has 3 sides that are all the same length is going to look like this. I didn't measure it. It may not be perfect, but it's pretty close where all 3 of those sides are going to be the same. If I wanted to get out a ruler, I've got my yardstick here. Yardstick, dropping my meter stick. So I could measure it and say, okay, that one's about 6 1/4 inches. Oh wow, that one's maybe just 6 inches. 6 inches. So I made it just slightly too long there, so I could do something like that. And then I'd have 3 sides that are all 6 inches. Okay. The next example says, draw a rectangle where all the sides are the same. Do you know what that shape is called? If I draw a rectangle where all 4 sides are the same, we're going to have a square. So, a square is always a rectangle, but a rectangle is not always a square. Anytime you see a square, it's also a rectangle because it's a 4-sided shape. It has right angles, which we're going to learn about in a future lesson. So right angles, 4 sides, and in this case, the sides are all the same length, so that makes it a square. All right. The next problem says to draw a rectangle that has sides that are 2 centimeters and 3 centimeters long. Well, so that you're able to see it on your screen here, I'm going to make mine 20 centimeters and 30 centimeters. So I'll start out using my ruler to draw a 20 centimeter line. And then I want 30 centimeters for my other side. So using my ruler again, I'll go down to the 30 centimeter mark. And then I can do the same thing on this side. Oh, oops, I got a little bit crooked there because I'm not holding it. And then we can close it off. I don't need to measure that last side because I already measured the top and it was 20 centimeters. So now this side we'll pretend that it's 2 centimeters and we'll pretend that it's 3 centimeters because that's what your book says to do. Okay? All right, finally, we need to talk about, I call this the anatomy of a circle. These are the different parts of a circle, and they're words that you are going to need to know now and into the future using this math book. So this is a circle. The definition of a circle is that you have a set of points that are all an equal distance from the center. So what that means is I have a center. I can put my ruler anywhere on my circle, and this distance should be the same as this distance, which is the same as this distance, or this distance, or this distance, anywhere that I look on the circle. The edges of the circle are all the same distance away from that center point, okay? The other words that you need to know are the words radius and diameter. Okay, The radius is that special distance from the center to the edge of the circle. Doesn't matter where you look to find the radius, because remember, it's all the same distance, but the radius is just from the center to the edge, whereas the diameter goes from one edge through the center all the way over to the other edge. So think about this carefully. If my radius is from any point on the edge to the center, and my diameter goes from the edge to the center, straight across to the other edge, this section and this section, first of all, are equal. Secondly, they're both radiuses, we say radii, of that same circle. So they'll be the same distance, and it can be considered two radiuses. Anytime you have one circle and you measure the radius and the diameter is always going to be 2 times the radius, because you have one radius on one side of the circle and then one radius on the other side of the circle, and put those together and what you get is a diameter. All right, so this question says, if the radius of a circle is 2 centimeters, then what is the diameter? So here's my circle, here's my center. Remember, the radius is from the center to the edge of the circle, so that's 2 centimeters. And the diameter goes the whole way through. So if this side is 2 centimeters, this side is also going to be 2 centimeters. So you want to add them together to get the diameter, which would be 4 centimeters. All right, at this point, your textbook shows you how to use a compass. I'm not sure how to do that from this virtual classroom setting. It's more kind of a one-on-one thing. If you have a compass at home, I'm sure you have a parent or someone, older brother and sister, that could help you use it. But I have a little bit of a trick that I use to draw circles, because a lot of times I have kids that go, I don't have a compass at home. So let me share with you my trick. It does require needing a ruler. So to make a circle, you're going to draw the center of your circle. And then you're going to decide what you want the diameter to be. So in this case, let's say the diameter is 10 centimeters. So I'm going to use my meter stick here. You could also do inches. And I'm going to put the 10 right there on the center of my circle. And then I'm going to put a little point 10 centimeters above it. Then I do the same thing right below it. Put my meter stick right on the center, and then I put a little point at 10. Then I do the same thing to the right, 10 centimeters, and to the left, 10 centimeters. So now I have 4 points. I could make a circle out of that, but it's not going to be very accurate. The more points I make, so I'll go halfway in between these two here, and then halfway in between here, and then halfway in between here, and halfway in between here. At this point, my circle is going to be pretty accurate because I don't have a lot of space from one point to the next. But like I said, the more points I go in there and put, all being 10 centimeters away from my circle, the more accurate my circle will be, because it's like connecting the dots. The more dots you have, the more accurate your lines will be. So there's another, 10 centimeters. So if you notice, this side has a lot more dots. It's going to be more accurate if I start to connect them now, making sure I go through every dot. I end up with a pretty accurate circle. And then this side, I didn't put as many dots, but I think I could still get pretty close. I'm not loving that side of it there. If I had more dots, it would be more accurate. But there's my little cheater's way of drawing a circle without a compass. Okay, you have a couple of lesson practice problems. The first one says draw a triangle with two sides that are the same length. You are going to need a ruler so that you can measure your two sides. And two sides, that's easy. That's awesome. Doesn't matter where you want to put it. Right now I have an inch ruler instead of a meter stick. So let's say I make this one 4 inches. Then I have to make another side 4 inches. And then I don't even need the ruler. It doesn't matter how long that is because these two are 4 inches. So this right here, if I put a notch in the middle of my line segment, what that means is that these two are supposed to be the same length. So if you don't have a ruler and you want to do this with mathematic notation, you could draw a triangle where you go, well, they're about the same length. They're supposed to be. And then you just put those notches there, and that's math talk or math notation for these two sides are congruent. They're the same size and the same shape. Okay? Problem B says, draw a rectangle that's about twice as long as it is wide. So about says I don't need to use a ruler. So twice as long, so there's my length, as it is wide. So I'm only going to want to use about half of that. So maybe like there. And then I'll finish it off. So this is about half of the length. The length is 2 times the width. Problem C says use a compass. So if you have a compass, go ahead and pull it out and try this. But if you don't have a compass, you can use my cheater way to do it with just your ruler, okay? So use a compass or a ruler to draw a circle with a radius of 1 inch. So it would be really tiny for me to do on the board here, but your radius is going to be 1 inch. So that's approximately the size. If you're doing it, I want you to actually measure and make sure you're doing it accurately. But remember, this is going to be 1 inch, and this is going to be 1 inch. So the whole way across the circle will be 2 inches. And the final, oh, nope, 2 more questions. What is the diameter of a circle that has a 3-inch radius? So here's my circle. They're telling me from here to here is 3 inches. So they want to know what's the diameter the whole way across. Well, this is 3 and this is 3. So my diameter will be 6 inches. And now the final question, what is another name for a rectangle whose length is the same as its width? If you have a rectangle whose length is the same as its width, I went a little bit long there, what do we have? It's a square. Go ahead and answer, babe. Have a wonderful day. Now it's time to start your written practice, which is on page 130 of your textbook. I will see